In this video, I'm going to show you how to use R to compute the conditional distribution of log wages given the education level. Let's start with the routine to set the working directory. See the previous videos for the details about the initial steps. I put links to the previous videos from the description. Also, one of the previous videos demonstrates how to download the data that we are going to use today. Open the new script window. And I will start with the same set of lines from the previous videos. Here we are loading the package to load the Excel data. And now we are loading the CPS data. Format the CPS data in the R's data frame. And now let's look at the first few records of the data. This is the CPS data. As usual, we are going to start with the construction of the wage variable. And let's review from the previous video on how to compute the average wage given demographic characteristics. The average wage for men and the average wage for women. We've already seen these results in the previous video. Likewise, we can compute the conditional medians. We only need to copy and paste and replace the mean function by the median function. The median is typically different from the mean because the wage distribution is usually skewed. Today, we are interested in the conditional distributions of wages given the years of education. We start by copying this line and augmenting the conditioning criterion by adding the years of education. Let's say we are interested in the subpopulation of individuals who obtain the college degree. We can select such a subpopulation by equating the education to 16. Observe that this conditional mean is larger than the previous unconditional mean. We next want to repeat this exercise for various years of education. So let's first try to find out the list of years of education we want to study. Let's enumerate the years of education contained in this data. These are 0 to 20, mostly even numbers. I'm going to make a list of numbers starting with 4 and ending with 20 and only taking even numbers. I'm next going to make a placeholder to store the average conditional wage given each year of education. I'm going to call it mean underscore log underscore wage underscore man, and we can use the array function to construct such a storage. Let's make an array of 9 slots, where each slot is containing the value of 0. Repeat this also for women. Before proceeding, let's check that nothing is wrong. So the list of years indeed contain the even numbers from 4 to 20. And the storage for log wages have the same length as the list of years. We are going to use the for loop to repeat the same calculation across different years of education. The R syntax goes as follows. Let the index run from 1 to the length of the list of the years of education. This is the basic syntax for the for loop. And here is the running variable, running from 1 to the length of the list of years of education. Now we are going to insert the program to be executed repeatedly inside a pair of curly brackets. We are going to copy this line and insert it inside the for loop. Let's focus on the log wage. Previously, we were focusing on the subpopulation of individuals with 16 years of education. Inside the for loop, however, we want to use the generic years of education indexed by the running variable. The index I type here corresponds to the index that I wrote here. In the first iteration of the for loop, the index is equal to 1, so it computes the average log wage for 4 years of education. In the second iteration, it computes the average log wage for 6 years of education, and so on. We can use this storage to store the computed average log wages. We refer to the slot of the storage by using the same index. Here, we are assigning the right-hand side object through the assignment operator to the left-hand side. Now let's run this for loop. We need to visualize the outcome of this for loop. So let's display the contents of this storage after the for loop. These are the average log wages across different years of education. We can match these numbers with the list of years of education by using the cbind function. This function conducts the column concatenation of the two vectors. For 4 years of education, the average log wage is 2.4. For 6 years of education, it's 2.4 again, and so on. For 20 years of education, it's 3.8. It may be more convenient to represent the same set of results through the figure. We can use the plot function, put years on the x-axis and the mean log wage on the y-axis. Observe the increasing function of the mean log wages as a function of years of education as expected. In fact, we can turn this scatter plot into a line graph. The type option of the plot function will do this job. We can see an almost linear function, especially past 10 years of education. This observation motivates the linear regression we will study later in the semester. We can add points in addition to the line by changing L into B in the type. Now let's repeat the same procedure also for women. Copy and paste these lines. Change men into women and change 0 into 1. Let's now display the results for women along with the results for men. So we can now compare the results across gender as well as across years of education. Among the high school graduates, here's the average wage for men, here's average wage for women. And for the PhDs, here's the average wage for men and average wage for women. And finally, let's repeat the graphical presentation of the results for women as well as for men. So here we change the men into women and put the par function in the line between the two plots so we can overlay the second plot on top of the first one. To distinguish the two series, I'm going to use the different symbols by invoking the PCH option of the plot function. And let's also put the legend. The 4, 4 location should be good. It doesn't seem correct. We need to set the identical widening values between the two plots. Now we got it. This graph is informative. First, for men, we have this series, which is an increasing function of the years of education, and also likewise for women, it's an increasing function.